Alright, now let's go on and move forward with rule number 3. Now this rule is basically known as a constant times a function. And what does it mean? Well, in simple terms, if you see over here, let's say we have another equation, right, g of x, and that is multiplied by a constant. Now in our previous rule, the constant rule that we looked earlier, the derivative, or when we try to differentiate the f of x in terms of the constant itself, it was always coming to 0, right? But in this case, it is constant times a function that has an existing x value, right? So in this case, what happens when we try to differentiate it, or when we try to find the derivative in terms of x, we see that the constant remains the same. However, the equation g of x, now we have to find the derivative of g of x in terms of x. To give you a better idea, what this means is, let's say we have an example, 10 times x raised to the power 4, right? Here, your 10 is basically the constant. And the g of x, the function, is basically x raised to the power 4. Now, a function is usually separated by either plus, minus, in this case, or either a multiplication sign and a division sign, right? So in this case, it is a multiplication sign. So that being said, how do we solve it? Here is the steps. We bring that 10 outside, or we keep it simply on the left hand side. Then we use the same rule that we apply for the power rule, right? We bring so in this case, just forget about the 10 right now, right? Look over here, this is just a power rule. We brought the 4 down and we multiplied by the x as raised to the power 4, and that was subtracted by 1, right? The only difference is we have a constant in this case that is multiplied by the entire differentiation in this case, right? So what this means is basically, now this function, let's try to solve it. 10 times 4 becomes 40, right? And this becomes x raised to the power 3. So this is how we solve for constant times a function. Good. Now let's move on to some of you more examples in this case, right? So here are a few more examples. Now we're going to apply the same concept, which is c times g prime of x, right? So in this case, we can go ahead. Now to make it more simpler, I'm doing the steps completely from step 1, step 2, and step 3, which is expanding it so it's easier for you to follow along, right? So how do we do that? We basically put the 10 aside, times we apply the power rule for this one. So we just hide that 10 value for now. So 3 comes down, that becomes 3 times x raised to the power 3. Now it has to be subtracted by 1, which basically f prime of x means that this becomes 30 x raised to the power 2, right? Now you don't need to mention this step in the exam. You can directly go ahead and solve for this. What I mean to say is, let's take an example for this one, right? So in this case, f prime of x is basically, now there's a hidden 1, remember, right? There's always a hidden 1 in this case. That hidden 1 multiplied by 15 by 2 is nothing but 15 by 2. No changes. I directly multiplied, right? I didn't go ahead and do this step. And then that 1 on the x, I can write it like this. 1 minus 1, that becomes 0. And we remember from the previous example, any variable raised to the power 0 or any number raised to the power 0 is always equal to 1, right? So in this case, your 15 by 2 becomes times 1, which is nothing but 15 by 2, right? Easy. Now this one is a bit tricky, so keep in mind the steps in this case. So when we try to find a derivative in this scenario, we need to remember that this x, right, the value of x is at the denominator, and we need to bring this at the top. But when we try to bring it at the top, two things are going to change. One, the sign, which is the root. To make it simpler, we're going to convert it into fraction, raised to the power of fractions. And number 2, when we try to bring x at the top, the sign inverses. It changes from positive, because over here it's positive, to negative. Now here's a simpler form, right? Before we find the derivative, let's try to convert this. I'm going to convert this. That is minus 4. I convert this x, and to give you an example, what root of x, when we try to convert, it is nothing but x raised to the power half, right? Simply. Now this number, when we try to take it up, the sign also reverses from the power fraction, right? So that becomes minus 4x raised to the power negative 1 over 2. So that's my equation now. Now let's try to find the derivative, right? So minus 4 remains the same. I'm again going to follow with this step because to make it easier for you guys to follow along. So minus 4, then that is multiplied by that half comes down because of the power rule. But remember, this is a negative half, right? Always remember to check your signs. Most of the time we make mistakes in this step. Always check your signs because most of the time we make a lot of mistakes in this case, which results in an error at the end and losing out a lot of marks. So make sure you check your signs, right? So minus 4 times minus half, and then this again is multiplied by x. Now in this case there was a minus half, right? Subtracted by 1 because of the power rule. Now that is the rule for the power rule, the PR. And let's try to simplify it a bit more. Minus 4 times negative half. Remember, minus sign multiplied by minus becomes positive, right? So I'm going to write positive here so that you guys can understand. But you don't need to write the positive sign when you're trying to do it. So that becomes 4 by 2, right? And this we can also simplify it further to make it just 2, but I'm just going to keep it right like that. Then we have x, 4 by 2x raised to the power. Now this has to be subtracted, but there's a minus sign over here and a minus sign here. So that becomes we need to add these two, right? You can do it in your calculator to make it easier for you, which would become minus 3 by 2. Now this hasn't finished because there's one more step. One is that we need to simplify this fraction because we can do that. Second, we need to bring the x at the bottom, right? So how do we do that? We make it, this becomes only 2 because we can divide that 4 by 2. And now we bring the x at the bottom, but when you bring the x over here, we need to remember that the sign will have to reverse. It becomes a positive, plus 3 by 2. So that's your answer for this. Now let's move on to the next one, which is the next rule. And this one is a rather easy one, which is a sum or difference of a function. Now let's say when you have two functions, u of x as well as a v of x, and they're either you're adding them or subtracting them, these two functions, and both these function has the x variable which you're trying to find a derivative of in terms of x, then the rule says that the f prime of x, which is when you try to find a derivative or the first derivative test, is basically you first find the derivative of the u, the first equation, and plus or minus, taking the same the signs from the top, you find the derivative of the other function as well. Very easy. So what this means is, let's say we have an example, and again remember that the equations are usually separated by either plus, minus, multiply or divide sign, right? So in this case we have two functions. This is 5x squared and root of x, right? So first we try to simplify this x root of x, right, to make it easier for us. Root of x is nothing but root of half, right? So now let's try to find the derivative of 5x squared using the constant times the function. 5 times 2 becomes 10, because you remember when we try to do it, in this case, we keep the constant separate. We bring the top, the power at the bottom, and then we multiply by the constant, and then we multiply by the x, right? So 2 times 5 becomes 10, and then your x is 1 minus 1, right? And then plus sign, we're going to take the same plus sign, but in this case root, we're going to solve for x half, right? X raised to the power half. That becomes half comes down, and you have x because of the power rule, it comes down to be multiplied by the x, and half is subtracted by 1. So in this case what happens, this becomes this becomes 10x, because 1 minus 1 is 0, right? Oh wait, 1 minus 1 becomes 0, so x of 0 is nothing but 1. So what this means is the fact, look over here, I made some mistakes, and this mistake costed me some marks if this was an exam, right? So what was the mistake? Check again. There is a 2 in this case, right? But I wrote 1, and that would have resulted in 0 over here, which would given me a different answer. But in this case it is a 2 in this case. So 2 minus 1 is 1, right? So always remember to check again, always check. So this becomes 10 x raised to the power 1, and then we add the values, this becomes half x, but when we try to subtract by 1/2 complete, right, this becomes negative half. And we know that we can solve this even further because x negative over here, we can also bring it down, right? We should bring it down. But you can also leave your answers over here, it's completely fine. But if you did try to bring it down, what would the answer be? That would be 10x, because there was a hidden 1, so any number or variable raised to the power 1 is the value itself. So we're just going to leave that, and then this becomes plus 1 by 2, right? And then x, we bring it down, so that becomes 2x raised to the power half, right? Now in this case, if you see, I brought it, and this is a positive half. Why? Because when we try to bring in the denominator, the sign reverses, so positive half. But you can also write this as 10x plus 1 over 2 root of x. Same thing. Okay, now let's move on to the next one, which is a product rule. Now this one is a little bit trickier than the sum or difference of a function. So what this says, when you have two functions, u of x and v of x, and you want to find a derivative in terms of x for that function, how do we find it? So the rule states that for the first function, right, you have to find the derivative of that u, which was your first one. I'm just going to write number 1 and 2, right? So your 1 has to have a derivative. You find the derivative of that equation. You multiply it by the v equation without the derivative, which is the second equation, right? 2. So that's your first step. You take the derivative of u, multiply it by v of x, and then you add them in this case. So always remember, when there is a product rule, you add the values. Always remember that. Then we have the v of prime. So in the first time, on the left side of the plus, we did the u prime, but in the second one, we are doing the v prime, right? Times u, keeping the same thing, u of x. So this is the formula for the product rule. Now let's give an example to visualize it in a simpler form. So we have two equations, x squared minus 2 times minus x raised to the power 3. So I've written over here that this one is your u and the second one is the v, right? So let's try to solve this, but make sure you also remember that you don't necessarily have to solve for that particular rule and at one time, right? It could be two rules at the same time. So in this case, in the first equation, which is u, there's another one, which is the difference of a function. You see, x squared minus 2. And there's another one, the power rule, because of the x squared, right? So how do we solve for this? Well, basically, first we apply the main rule for the product rule, because the brackets comes first, right? In this case. So that becomes, so we do the u of the derivative of u. U is this one. And when we try to find the derivative of this one, we need to do the derivative of each of those values within that bracket, right? In this case, there's only one because the constant is just 0, right? So that becomes null. It's not gonna be there. It's just 2, right? The 2 over here, the top of the power comes down, which becomes 2x. Now that 2 will be subtracted by 1 because of the power rule. So 2x raised to the power 1. That's for u. Then we multiply it by v. You see v? V remains same. So I'm going to keep it safe, minus x raised to the power 3. I'm keeping this in bracket because there's a negative number. So so when I come back to the equation, I know that this is a negative and I don't mess up in my later steps, right? Then we have a plus sign. Always remember, product rule, plus sign. So now we have v of derivative. Now we need to find the derivative of v. V is what? Minus x raised to the power 3, right? Now there's a minus sign. Always remember, it is when we try to bring the power down, it has to be multiplied by the negative sign. So that becomes, I'm just going to write in bracket again, minus 3, and that x becomes 2 because 3 subtracted by 1. Okay, so that's my v, derivative of v, and then I'm going to times that with u. U I'm going to keep the same, which is x squared minus 2. So x squared minus 2. I'm going to keep this in bracket again because we're going to multiply minus 3x squared with the entirety of that function inside. So let's try to simplify this in Now when we have the formula applied, we just need to simplify it even further because we cannot leave it like this. If you leave it just like this, you're going to lose your marks. So we need to simplify it even further. So let's try to do that. In the first case, it's very simple. This multiplied by minus x raised to power 3 becomes just nothing but there's a minus sign, positive sign, so the answer will be negative. 2 would be same. There is no change with 2 because there is no constant at the front of them. And then x just becomes 4, right? Because we have x of 1 and x of 3. You need to add them together, x4. Then we have plus sign in between. And after this, we have minus 3x squared times x squared. So I'm just going to put this in brackets. The first one we multiply with x squared. And then again, we multiply with minus 2x, right? So in the first one, we have, again, minus 3 x raised to the power 4 because x2 and x2, you add them together when you're multiplying the two variables, which is the same variable. So you just add them, the powers, becomes 4. And then in the second one, we have minus 2 3 is 6 and x squared, right? So that's the value. Let's try to simplify even further. When you try to simplify, this becomes 2x raised to the power 4. And now you can remove the signs. This is just minus 3x4 and minus 6x squared. Now, do we see anything common? Yes, we do see these two in common, which has the same variable raised to the power 4, right? In that case, what we can do is we can solve for it even further. That becomes minus 2 and minus 3 becomes minus 5. Because there are two negative signs, we just add these two values together, minus 5 x raised to the power 4 minus 6 x raised to the power 2. So that's your answer in this case, right?